Hello everyone, François Montigny speaking from my home office in Massy. So welcome to this new webinar, which is our second webinar about training module update. So I'm head of education programs from L-Acoustics, but I'm not going to be the only one on this one. Actually, the most of this update is going to be provided by Vic Wagner, so our main training referent in the US. Hello, Vic.
Good morning. Good morning, everyone. Looking forward to it. Welcome.
Yeah. Thank you, Vic. So to accept to do this update, we have also again a bunch of moderators to answer any question in many different languages. So we have Alex Soto with us.
Oh, hello, François. Hey, hello. How are you? Well, it's another beautiful day here for a webinar. Thank you guys for joining us today. Buenas tardes, buenos días, Latinoamérica. Bienvenidos una vez más a nuestro webinario del día de hoy. Aquí estaremos atendiendo sus preguntas en español. Gracias por acompañarnos. Thank you, François.
Gracias. So we have Thomas in Germany. Hi, Thomas, unmuted.
Now I think I'm unmuted. Hello all, I'm Thomas from Germany, and I hope you have a great webinar today. I wish you all a happy time, and feel free to ask questions. We are happy to answer your questions. Enjoy.
We have Arnaud in France. Bonsoir, Arnaud.
Bonjour. Bonjour à tous. Hello, everybody. Nice to have you with us tonight.
We have Sergey in the UK.
Hello, everyone. Привет всем. Enjoy this webinar. Наслаждайтесь семинаром.
And Dan is with us also tonight, or this morning for the US.
Yeah, be on the morning side over here, but yes, it's great to be here and great to see so many people from around the world joining these webinars. So as Sergey has the wonderful brick wall, I'm trying to add the blue curtain to the experience here. So thank you, Francois, and everybody enjoy.
Thank you all. So I think we can start. So again, Vic, could you put the PPT on your side? Oh, you want me to just send me this? Vic, please, could you share your screen? Because I think it would be really more comfortable if you could.
You should see that.
Yeah, I think. Yeah, okay. Thank you, Vic. Yeah, so first, this is an update. So again, it's going to be mainly focused on people who already attended to system fundamentals training in the past. Meaning that we are not going to cover the full module, obviously, but we're going to focus on the new edition. And actually last year, or maybe now 1 year and a half, there's been some big changes in this part of the system fundamentals training. So in the past, we would have a module called amplified controllers. And now we have something else, which is called drive system. So what is a drive system at L-Acoustics? So now we're going to talk much more than just the amplified controller part. We're going to talk about all what's in between the console or the program source and the loudspeaker. So what's all in between? That's the amplified controllers, yes, but also now I would say one of the main addition to our system, which is kind of bringing us closer and closer to the console. It's a P1. So our P1 has a front-end station in our system. And in between, we have now we have the LS10 for the network management side of it. We have the software, but also cables, etc., etc. So all what's in between the program and the loudspeaker system itself. So how are we going to cover this in our module? Actually, we have 4 different steps. So we talk about the audio distribution, we talk about the data network, we talk about the loudspeaker processing, and we talk about the power amplification. So that's really our 4 main focus in this module. Actually, in the module, we start from the loudspeaker and we kind of go downstream into the audio chain. So we start with the power amplification and then we end with the audio distribution. So there is one part which is really focused on the implementation, so the hardware implementation. So meaning that we talk about how you're going to set and configure your hardware. And then there is a second part which is more focused on the user interaction with this implementation, meaning that we talk about the front end panel for the amplified controllers, but also obviously there is a large focus on LA Network Manager. So I'm just going to go quickly on just the first slide of each section for the hardware really quickly. So first is power amplification. In this part, there is actually not much about, I would say, addition to this part, just a bit of reorganization, but we talk about power amplification capability for each amplifier. We talk about the effect of cables, actually, which is something which is quite interesting. Then we have a second part, which is loudspeaker processing, where we tackle a bit more what we call the distributed processing, which happens actually within the amplified controllers. So all about the preset, etc. Then I think that's where I'm going to hand over the presentation to Vic. We have this part about the data network, which is not that different than what was in the previous module, but actually it makes a great introduction to all about the audio distribution, and especially audio distribution over Ethernet through Milan-AVB. So Vic, I think it's I'm going to let you go on with this presentation.
Certainly. So kind of coming off of this, we'll talk about data network. In this case, you can see we've got our LA Network Manager connected directly to the amplified controllers. So what we want to point out then is in the L-Acoustics ecosystem, we have LCOM proprietary, runs on TCP/IP protocol, allowing us to have unique network up to 253 units. So you want to assign an IP address unique to every unit that's on the network. Here on the back, on the back of an LA12X, you can see the network connections. You can either in or out in either one of those. Obviously, there are gigabit network connections for the LA12X, for all LA12X, for LA4X, serial number ending in 5,000 or more. Again, remember everything else, including the P1 for gigabit. And then when we've got the LA8s, it's a 100 megabit connection. So this allows us to control the amplifiers or the different parts of the drive system from Network Manager. So that being said, what we're going to do is connect to the computer. So in this case, we've got our USB to Ethernet adapter. In the case of all the LA2XI, LA12X, LA4X, and P1, we're going to have EtherCon connectors, and then obviously a network switch. In this case, an Ethernet switch, gigabit minimum, or you could have a ADB enabled switch if you plan on using doing audio distribution over Ethernet. So a couple just kind of overview of network topologies. Again, the first one we're going to talk about is daisy chain. So series scheme for this. Yep. So in this case, then we've got the computer connected to all the amplified controllers, obviously the LA4X and 12X first in the daisy chain, and then older units after that. So in the case of this LA4 or LA8 after that. And the reason that is obviously one's the gigabit network traffic's not gonna, it's gonna pass to the 10100 traffic, but the 10100 won't allow gigabit traffic through. So want to remember that, always go from newer units to older units in that case. And obviously in this case, we want to pay attention to have a maximum cable length. We don't want to exceed 100 meters or 328 feet. So again, we don't have it pictured here, but on the, well, you can see it on the bottom there, LA8, there's a specific in and out. We want to make sure that we have the Ethernet going in the out on those. It doesn't have the ability to cross over Ethernet topology on the back of the controller. The next topology we're going to get into is a star topology. So shown here is a LS10 switch, which we'll talk more about in a second. And then we've got each of these network connections going to LA12X or an LA4X. Obviously, if one of those units lost power, it wouldn't affect the others in the star topology. So again, we want to make sure that we've got our cabling a minimum of 328 feet. Hybrid, this is a mix between daisy chain and star. So in this case, we've got switch start out to each of these and then daisy chain between each unit, the newer unit into the older unit, mindful of the in and out connections on the LA8, and then network manager as well. Cool. So a lot of this stuff, obviously network distribution, this stuff's been around for quite a while this far in the world of digital audio and DSP amplification. So we're not going to spend a lot of time, but I'm just going to go through audio distribution. It's kind of different formats that we're dealing with, starting with analog, getting into AAS, and then a quick introduction to ABB and Milan audio distribution. So on the back of the LA4X and LA12X, we've got our analog connections here. We've got our XLR connections there. There are 4 connections with the through, and then digital as well. The top left set of connectors there being AES-AB, the bottom left being AES-CD. Obviously, if you were to run Ethernet into those, then we'll be running over ADB using the Ethernet ports. So allowing for redundancy with fallback options. So in this case, we've got our LA4X and LA12X. We have our AES-AB falls back to XLR-CD. ADB, you can configure to have ABCD fall back to XLR-AB and CD. In the case of analog, we'll just kind of go over this, just give it an overview of what we're talking about. So again, on the left, you can see here we've got our energy or voltage, amplitude showing plus minus 0.775 volts, and then you can see our level over time. And then this voltage variation proportional to acoustic waves, pro line level distressed in dBU, and electrical signal frequency range is equal to audio content. Just kind of some basics there with what that is. In the L-Acoustics ecosystem, we're looking at so line level mono inputs, electronically balanced, max level at plus 22 dBu, impedance is 22 kiloohms. And remember, there is a link, the through on the back of for each input, passive link with the ends. There you can kind of see everything connected, showing A and B connected and daisy chain to an amp below it. Not showing with the actual wiring there is the CD, which would be the set of connectors below the LA4X and in the case of the LA12X. In the case of the LA8, it would just be the two inputs, analog input A and B. Once you get into the analog inputs, we're going to convert to digital to feed the DSP. In that case, it's 130 dB of dynamic range at native 96K sampling rate. So again, we want to remember that we don't want to link more than 22 units together to maintain voltage transfer loss. Start losing about a dB, a standard source impedance of 100 ohms. So in that case, we just want to make sure we don't have more than 22 units linked together, which I feel like yesterday we talked a little bit about that. If you guys want to go back and rewatch some of that, is having having all these analog fallback. I remember Tony was mentioning this. That it's a good standard, gold standard to have an analog fallback in many redundancy systems, and we want to make sure when we're setting that kind of stuff up, even though if we're going to prioritize ADB traffic, that we don't have an excess of amplifiers on that analog in the analog signal chain. And also, we want to make sure we don't have cable lengths that are longer than 350 feet or 100 meters from the source to the last unit. So it's important to keep an eye on that stuff. I feel like these analog drive systems, including jumpers and mass connectors or mult connectors, things like that, can get quite lengthy. So our next topic then is looking at AES. So again, what we're looking at is self-synchronizing digital audio stream point-to-point distribution of 2 channels over 1 balanced 3-point XLR cable using the AES EBU standard. So in this case, it is pulse code modulation or PCM audio data embedded with an embedded media clock. Synchronous transmission is a series of electrical square waves. And you can see down below there the pulse code sampling and quantization sampling at the rate of the clock. And I think also then you see here on the lower right is our synchronous, our AES signal described as 1s and 0s, basically, digital signal, square wave frequency proportional to the audio, sampling frequency. So again, in the L-Acoustics ecosystem, we're looking at 3-point XLR sampling frequency, 44.1 to 192K, word length obviously 16, 18, 20, or 24 bits, active link with fail-safe relay, digital signal refreshed at each unit. So remember, there is a limit to that. It's not a distribution amplifier. Comes up frequently in the questions that I get. So in this case, we've got LA4X and LA12X connected. The first input A and B through the first, and then the second one's not used. The second one's not used in this picture, but that would be the connections. I think my mouse should show up there. You can see here the connections below would be C and D. So what we want to maintain is obviously, like we talked about extensively in the last couple of webinars, what we had looked at was maintaining synchronous latency between all the units controlling within the line source. So it's always going to maintain the same latency when we go to sample rate, and especially sample rate conversion from 44.1 up to 192. So in this case, this constant propagation delay of any input sampling, so it's always going to be locked in the case of LA12X running a standard preset would be about 3.84 milliseconds from AES. Low jitter, high audio quality. So isophase, all of these controllers are receiving the signal at the exact same time, regardless of the sample rate conversion going on between the input signal and into the DSP. So we mentioned using 192. I think there's some devices out there that you can do 192, but we want to avoid using those over sampling frequencies or clock frequencies over 96K. Obviously, this is going to be lost when it sample rates down to the native 96K that the DSP uses. So we don't want to have conversion errors or lost data with cable length. So a quick kind of overview of that. I like this graphic to the right here. You can see our square wave looks quite nice, and then as you increase the amount of units that are in line, you start to increase jitter or kind of deforming the shape of that square wave to become more like a sawtooth wave. And eventually, the sample rate conversion is going to have to reject that signal and throw it out as a bad clock because it's no longer maintained. So the best rule of thumb is to maintain good cable quality. And we've got some recommendations here, but ultimately just keep a good idea of how many units you're going through. I feel like it adds up pretty quick at times, so we want to make sure we're not going over 22 units to keep that.
Maybe I can add something on this one as well. Mm-hmm. It's really important as well to understand the difference between a standard XLR cable and the one that we're going to use for AES. So when you use analog, you are interested in transferring the voltage. So really so what we use is what we call an impedance mismatch. But with AES, actually, our electrical signals, that's just square wave, and we are not really, I would say, interested in maximizing the voltage, but really in maximizing the accuracy of the shape of this square wave. So Vic was just mentioning this kind of distortion that can arise with too many units, with jitter. And for the cable, actually, that also has a great impact, a big impact. We use a special cable to have now an impedance match, so that we avoid that at the end of the transmission, there is a reflection in the cable that is going to create some kind of internal comfiltering within the cable, and the result is actually the same as what you can see on the right graph. It's going to, this reflection within the cable, if you are not using proper cable, is going to distort the shape of the square wave, and then that's bad for your 0 or 1 recognition.
Cool, thanks, Francois. So that's just some recommendations here. And then remember, as we increase the sample rate, the signal becomes, that AES signal becomes more fragile. Thus, we aren't going to be able to use as long of cables. So here you can see 1,000 feet at 48, so half that length when we double the sample rate frequency. So minimize the number of cables joined together. I think that's a pretty common thing that happens, especially in rental and touring environments, is you end up with a lot of connections or going into some mult connector. So we want to try to avoid that as much as possible and use the same cable type throughout. So next, obviously, we've got ABB, like we talked about there. So again, real-time audio over Ethernet cable. In this case, so we're multicasting multi-channel audio streams on a local network. Again, using that pulse code modulation data with a discrete timestamp of audio format description. So in this case, what we can see is we've got scheduled transmission as a packets of bits. And then synchronization of network devices using a high precision common wall clock. So again, this has been it was a topic of discussion during yesterday's presentation, and a lot of the stuff we're going to be getting into this week. So what we've got here is this deterministic route through that's maintaining the same latency for the transmitted signal. So it's all going to be in the same time. Thus, by using an ABB traffic, we're guaranteeing a set delivery of packets that are time sensitive, and then any other network traffic that's taking place on the same network. So again, like control data that you'd have for the P1, LA12X, LA4X, that's all going to take secondary priority over the ADB traffic. So it's going to reserve bandwidth reservation up to 75%. So, and as this evolves, what we have here is then the Milan Group, and we've talked a little bit about this. So this is obviously the ADB is the evolution of audio over Ethernet as a technological enhancement for time-sensitive content, and then Milan is the application layer, is standardized ADB installation for pro audio products. So again, there's some on the bottom left here, we've got our network technology layer, legacy Ethernet over 1588, and we've got our legacy types there, and then we've got ADB Ethernet, and then the Milan Group allows us to specify audio stream formats, network redundancy techniques, media clock structures, network control and management, and then product certification as well. So we'll be getting into that definitely in the next couple slides and over the next few days for sure in these webinars. So I think what's really nice about this too is then this is our we have a group of obviously pro audio manufacturers that are invested in furthering this group and maintaining the Milan Group, so everything is interoperable between each manufacturer. So why is this important to our line source design? Well, again, what we talked about in this case is we've got everything at a fixed latency through scheduled presentation time. So all the controllers that are outputting are extremely accurate clock. Again, in this case, it's plus minus 20th of a sample at 96K or plus minus 1% phase shift at 20K. So what this allows us to do is maintain much better wavefront integrity in the line source. So the graphic here on the left is variable latency or an accurate clock, and then the graphic on the right, fixed latency or an accurate clock, maintains a more better wavefront integrity and less opportunity for interferences induced by latent elements within the line source. So especially for high frequencies that are more susceptible to these kind of interferences, and over long distances and things like that, we're going to have better transparency from our systems. So then another we talked about interoperability here. Again, what we're able to do is run this control data and run these networks between Milan devices and outside into just standard Ethernet devices. So in this case, you see our daisy chain topography where we've got our LA12X daisy chain to another LA12X, and there's obviously ABB traffic between those two, and then you have an LA8 outside of that ADB domain that's still transmitting control data, but it's not going to be transmitting ADB data into those units. Then the star topology as well. In the case of the star topology, we've got our ABB switch. Obviously, that's within the ADB domain, so it's transmitting audio to the LA12Xs, and then still transmitting control data outside of the domain, which is indicated by this box. So I'm just going to switch here. Yep. And then on the far right here, you can see we've got our ADB switch star topology to these other units. They're daisy chained from there, and then you have Ethernet to a non-ABB capable switch that's sending control data, receiving control data from maybe in this case an LA8. So you can bridge in stations, connect all these units together. You don't have to think about what ports you're using. It's quite easy to set up. So in this case, then ABB Data Recipients, just kind of some definitions. I think there it is. ABB Bridge manages traffic of ABB streams. A network switch is reception, buffering, and retransmission. So again, the LS10 network switch, ABB network switch, ABB Bridge. ABB listener can listen to ABB streams. Obviously, LA12X, LA2XI, LA4X, P1 are all listeners. Reconstruct the temporal signature or signal using timestamp sampling rate data. So again, LA4X and LA12X are ABB listeners, but it's important to note that they're also ABB bridges. There's 2 ports on the back of all these devices. They can be set up. It's basically like a 3-port switch. One connects to the DSP, and the 2 other ones connect to the 2 physical ports on the back of the unit. So then any LS10 or any avenue. So this is a kind of a quick overview of the LS10 and some of its features. Again, LS10, 10 for 10 ports, and on the back are 3. Obviously, this makes sense. There's going to be 3 amplifiers inside an LA Rack 2 ADB, which we'll talk about shortly. And then on the front, you have your 5 Ethernet ports to connect to any other amplifiers or LA racks to run that star topology or daisy chain. Also on the back are 2 SFP cages, allowing you to convert to optical signal to connect for longer runs. Also then back there is this terminal block. The terminal block allows us to input 24-volt backup power, so you can daisy chain these from 2 devices. And then also GPIO to control some stuff. But I think one of the great features is obviously the 5-second startup time, and that's very, very simple and usable, and it'll come up quickly, reboot quickly. Obviously, passive cooling, these would load side by side next to each other in the LA Rack 2, which I think in a few slides we'll discuss a little more here. So again, in the case of these ADB data providers, like we talked about, the P1 is an ABB talker, ADB bridge, and ADB listener. LA Network Manager is an ABB controller, so it can tell the different talkers and listeners what streams to subscribe to and listen to. The ADB talker multicasts audio data over the ADB stream. So you can see here, the talker connects to that within that domain using the ADB bridges, the LS10 in this case, and then LA amplifiers, LA12X, LA4X, and LA2XI, or P1. The LA ADB controller, then in this case, LA Network Manager, can run outside that ADB domain and can control the items that are in that domain as well. So and then in this case, we've got some actual kind of a use case here where you've got your LA Network Manager ADB LN controller, and then that controls connected to ADB capable Ethernet switch, and then obviously the P1 connected to that LS10, and then in this case you've got star topology to daisy chain with these LA4X or LA12Xs connected. That being said, then also you've some stream formats, AAF format 32-bit up to 8 channels, 48K or 96, maximum of 3% of a 1 gigabit bandwidth. The 2 millisecond presentation time from talker to listener latency. If it's outside of that, it's going to switch to the fallback signal, which we'll talk about that here in a second. And so for each listener stream selection and channel routing, we'll do that from LA Network Manager. So ABB plus LNet recommendations. So to ensure latency and time accuracy, we want to use Cat5 E or higher Ethernet cables. Now, obviously, just like our network protocol standards, we don't want to exceed 100 meters or 328 feet. And again, that's just standard Ethernet recommendations, nothing specific to ADB or Milan. And then AVNU certified devices, LA4X, LA12X, not what's shown there is LA2XI or P1, third-party preliminary switches as well, including the LS10. So then, in this case, 253 on a subnet, max number of L-Acoustics units, a P1, and LA amps on the network. In this case, 254 would be reserved for the ABB controller or LA Network Manager control computer. So we talked a little bit about being able to daisy chain these together. Because each of these units allows us to jump them together, we can do a max of 12 units daisy chained. So this graphic is kind of useful because it just shows us our switch hops. We've got our P1 being our talker, and then that's our bridge to one of our switches. That's our second hop. And then hopping between each of these, 3, 4, and 5, that's our maximum. Or that's in this configuration, we only have 5 hops. So we can do up to 12. So for most small systems, it's actually quite simple to daisy chain these and run this without any other ABB switch infrastructure. So in this case, the second jump in this diagram just repeats 3, 4, 5 because it's not an additional hop. So it's a kind of a good example of that star topology switching to, or hybrid topology switching to daisy chain. Another thing we can do is take advantage of the 2 ports and run rapid spanning tree protocol between all the devices. And what this allows us to do is allows us to have enables switch redundancy and cabling redundancy, protects against network loops. So in this case, you'd have a P1 connected to an LS10. The LS10s are just connected to each other. And then you've got both connections going to each amplifier, each LA rack 2 in this case. And this allows us that if one of those cables were to fail or switches were to fail, then you would fall back to the second just using the standard Ethernet protocol of RSTP or rapid spanning tree protocol. So just kind of breakdown of what we're seeing here. In this example, we've got our mixer, and our mixer's connected to P1. And you can see in the gray, it's analog, and then AES as the secondary. And then you've got AVB between the P1 to the LS10s, and then also then ABB to all the LA12Xs. On the right, you've got AES as your fallback. The fallback would be coming in directly to the amplifiers from the P1. And then there's maybe another location, maybe a delay location or something like that. And that's they're using LA8s in that example. So then you're going to use priority of ADB going to that P1 at that position, but then also running analog as a fallback from the front of house, front end P1. And then obviously priority out of that P1 AES, and then fallback from there to be analog into those LA8s. So basically what this is allowing us to do is basically a network off-ramp to get from ABB to AES and then maintain redundancy throughout. And then obviously you have dual cables for each. So this is a cool kind of overview graphic of all the different types we just talked about. So analog, hardware implementation, obviously point-to-point, direct output to input connection, standard XLR for one signal, and then AES rated XLR for 2 signals in the case of AES3. And then for the case of analog audio quality, high immunity to EMI, sensitive to ground loops. So again, I think we've all spent some time troubleshooting some ground loops in a large PA system. It's exhausting, so that's a concern. Again, in the case of the AES, we've got high immunity to EMI or ground loops, minimal clock jitter. So then on the bottom here, in the case of ABB, we've got network multicasting, routing versatility. Again, we can select up to 8 channels in that stream. No additional cables needed, using Cat5 from LNet for multiple signals. We want to have ABB switches, capable switches, high immunity to EMI and ground loops, negligible clock jitter, plus or minus 0.5 microsecond accuracy. So I think that's an important thing. Again, kind of pros and cons of each of the cabling infrastructure and their audio quality advantages. So, and I think just as these presentation slides are very procedural as to how we're going to integrate this into the L-Acoustics ecosystem. We're going to get more into these in the next couple days of presentations as the ADB topics get unpacked.
Yeah, Vic, actually on Thursday there is a presentation delivered by Etienne, I think, about actually about the same topic, the different audio distribution format, with a huge focus on AVB Milan for sure, and going deeper into all the technical aspect of it.
Yep. So how this integrates with the P1 station, and if you guys tuned in to yesterday's webinar, this would be somewhat of a review, but we're looking at the P1, the front and the back panel, analog, 4 inputs, 4 outputs, AES, 4 inputs, 4 outputs. Just to remember, this is 4 inputs, 4 outputs on each of those XLRs sharing 2 channels. So it's 2 connectors of in, 2 connectors of out. ABB, 2 over 8 channels, 8 channels over ABB, and obviously a bridge for any ABB traffic. Plus on the front panel, we've got 4 mic inputs. Yesterday we pointed out 4 mic line inputs on the front, not just for mic. Stereo, USB stereo media player on those 2 USB ports. Test signal generator internally that you can run to the system, and obviously headphone jack there on the right side. And then this D-sub connector near the power connector, that's for GPIO as well. So quick overview here is of signal distribution and common connection schemes. So collects program inputs. In this case, we got our console, and we've received signal from either ADB, AES, or analog. It goes into the P1. There you see we've got the media player as well. Maybe if we have to reboot the console, or one of those consoles is loading out, we could run 2-track from the media player. And then obviously it manages seamless redundancy schemes as well, so we can switch between those formats if one format fails. And then further in the distribution chain on the output side, we can take this and go in ADB and then output AES or analog to run to LA4, LA8, or P series. Also allows to distribute signal to third-party systems or in-house PA. We talked about lawn delays a little bit yesterday, or under balcony speakers. So a variety of applications there to allow us to distribute signal to all those items. So as far as audio redundancy, in this case, we've got front-end distribution to LA12X, LA4X, or other P1s. any redundancy, level aligned. So again, AES analog are always time aligned by default. AES analog ADB can be time aligned by the user's choice. Set this up within LA Network Manager. Available when using DSP buses for matrix mixer. To activate it in LA Network Manager from the front end P1. So again, in this case, you can see the example pretty straightforward here is our console that comes in AES to the P1. We're just going to use the Ethernet port to connect directly to our computer, our network manager computer. And then we've got in daisy chain topology, just Ethernet connected to all the LA4Xs. Our LA4Xs are connected. Maybe this is just a real simple system. And then if we're not going to rely on RSTP redundancy, but just rely on a different format for redundancy in this case. So all from the P1, level aligned and time aligned in this case, we'll be able to set up and run this AES to all the LA4X, and then also analog as another order to fall back in case AES were to fail. One thing I kind of misspoke there I want to make clear is that it's obviously up to the user to align level. We want to verify that the AES level is equal to ADB or analog, or however you want to manage those priorities. So that's all stuff that's easy to set up within LA Network Manager, which I'll touch on briefly once we go through the tutorial. So remember in the case of AES, we've got AES AB falls back to XLR CD, and then on the case of ABB ABCD falls back to XLR AB and CD, each pair analog or AES. So in this case, then analog redundancy recommended for easy and permissive implementation. So again, like we talked a little bit about, I remember Tony mentioned yesterday was in this case it's a pretty bulletproof. We have a single network connection between all these units, but we're really relying on that second format as our fallback redundancy. So then, obviously, we also talked a little bit here about being able to run using the Milan standard of dual ADB network redundancy. So then supported by Milan talker listeners of P1, LA12X, and LA2XI, not supported with LA4X. So each point, one distinct network. So then in this case, audio from one over the other, one disconnected from network, there's no dropouts. With the case of RSTP, there'll be a slight audio dropout while the network finds the next fastest path through the network. But in the case of dual ADB network redundancy, there's two networks operating simultaneously. So each network with its own IP address, and then LA network control via primary only. So in this case, you can see just kind of define some of these arrows here. The gray being the analog, the blue being the AES, LNet being this controlled to the network manager, if you can see my mouse on there. And then primary ABB being the black network connections, and then the secondary being the red network connections going between the two ports on the P1, and then one into a discrete LS10, and then the one port being primary and the second port being the secondary. All of that repeats itself within each of these LA Rack 2 ABB, which is shown down here. It might be a little small on that screen, but each port allows us to connect redundancy to each of those. So then in this case, we've got redundancy for the cabling and the network. So if we lose one of those networks or any of those cables, it will seamlessly fall back with no dropouts to the secondary network. The next topic then is just talking quickly about using the GIST-EQ, taking advantage of the P1 DSP buses. So then in this case, we can use the P1 of the front end functionalities to output to the system inputs. So in this case, we've got for input signal processing of the DSP buses using the matrix mixer. In the DSP bus within the P1, we have control over gain, polarity, mutes, delay up to 4,000 milliseconds, 16 EQ filters, and dynamics processing. By using the DSP bus, we incur a latency an additional latency of 0.39 milliseconds as compared to direct routing these, and we'll go over that briefly here in the next in the walkthrough or in our tutorial. Also, we talked quite a bit about this last week. Acoustic calibration and monitoring using M1, measurements using mic input and embedded generator, data management collection on all of those, and silent tuning using LA Network Manager in the M1 environment. Remember, in this case, though, this would be front-end DSP bus. Loudspeaker processing is still performed by the amplified controllers as well, not in the P1 only, exclusively. So because we're focusing on some of the new additions to the drive system here, we didn't talk exclusively about the low latency presets. There's low latency presets for monitor applications for a lot of the coaxial X series products. So in this case, our standard preset would be 3.84 for LA4 and LA12X. And then if you add the P1, we go from 3.84 to 4.8. Just by going through the P1. If you run the P1 ADB time-aligned redundancy between the P1 and the LA4X or LA12X, then we have a total system latency of 7.17 milliseconds. And then obviously subtract 3 from that to get to our 4.17 and for low latency presets. Outside of that, we just want to talk about the LA Rack and LA Rack 2. LA Rack 2 being LA Rack 2 ABB standard solution for rental, 9 rack unit standard solution. In this case, 3 LA12Xs with 2 LS10s for the LA Rack 2 ABB. So obviously, there's 3 amplifiers. Each of those is on one leg of power, so X, Y, and Z. Distribution of mains voltage, analog, digital audio, and network. There's shock bushings in there for touring conditions, and obviously they're flyable for flying or stacking. Specific to the LA Rack 2 AVB, in this case, you take out one of those Blake panels and you're able to drop in single space with 2 LS10s. One of those LS10s for primary, one of those LS10s for secondary redundancy. Obviously, it comes with a kit to connect all those discrete Ethernet runs to each of the LA12X amplifiers, and also jumpers between the 2 switches for voltage redundancy on the 24-volt supply for the LS10. Francois, anything else you want to add in there? Cool. We'll keep going.
Not really. No. Thank you, Vic. I think now, yeah, you're going to demonstrate a bit LA Network Manager in live.
Yeah.
Or you're going to go through a few slides before that?
I think there's like yeah, we're going to go into it's not in this one, so we'll go right into Network Manager. So we're going to pop out of this presentation slide, and we'll I'm just going to switch over to my so you guys should be able to see this. I think.
Yes.
So in this case, cool. In this case, what we've got here is our system. We've been talking a little bit about this over the last couple of days, our Santa Barbara Bowl system. So in this case, what we've done is we've got our main system here. Here's our main K2 system, our subs. They're linked together. And what I'm going to do quickly is just create a group. We'll call it we'll just call this an all group. Click on new group. We'll call this all. And what I'm going to do then is I'm going to drag. I'm just going to multi-select each of these into the all group. So now contained within that all group are each of these child groups containing my sources. So that's all done. I'm just going to save that. Another thing to point out, a couple things here I'd just like to point out is we're going to talk about Autoclimate here in a second, which obviously we need to have calculated from Soundvision. If you look at my source settings here and you see my electronic settings tab is green, that means that the auto FIR algorithm has been executed on that line source. There you can see it's got my current atmospherics and my allowable headroom shown there. That's all good. And what I also want to make sure of is if there's any groups that I don't want to import into Network Manager, I can click this hide button, just like so. And anything that's hidden, I just hid the front fills, for example, will not import into Network Manager. So if you have alternate configurations, maybe if I have a system, maybe an outfill system of A15s or something, then I could choose to hide those if I didn't want to bring that into the network because we aren't going to use them that day. So just make sure you save all that stuff. And what I'm going to do then is go into, here's my network manager, and I'm just going to, I think this is up from before. I'm just going to close this. And I'm not going to get too extensive with all the control options and functionalities of Network Manager because we wanted to kind of make this presentation a focus on updated things in the last 12 months of revisions and releases. So I'm just going to focus on some of the newer features here. But in this case, I'm going to open up my file that I just saved. So I'm going to click on load. And in this case, then I'm going to click on my file, which looks like I saved about a minute ago, and I'm going to open this.
Just could you switch to your LA Network Manager screen? Yep. Sorry.
Mm-hmm. That should come up. Let me go through that one more time for the world that couldn't see what I was seeing. That being said, I'm just going to click on load here, and I'm going to open up my XMLP file that I've saved previously. And there you see my system come up that I've connected, that I've configured in Soundvision. And also you can just quickly verify that all the group associations are correct. So in this case, I'm just going to quickly toggle through all those. Here's my K2 right, my K2 left. Because I I linked my sources left to right, I'm able to see this, each of these FIR control zoning groups down the line there, and then obviously my parent groups as well. This is the all group that I just created. This controls all the units. So I'm just going to make this a little more ergonomic to look at. So in this case, I'm just going to move my FIR groups. I'm just clicking and dragging, and there we are. And then I'm going to put my main group on top of that. Again, I can just click the plus minus there and verify that that's correct. Now in this case, then I've got my subs. I'm just going to bring my subs in over here. Now by default, Soundvision exports the preset for these subs using the 100 hertz low pass crossover frequency. We want to switch that to the 60 hertz because we're using it with K2, if you remember from the preset guide. So in this case, I'm going to switch this to KS2860 C cardioid, and I'm just going to click and drag this group over here, and that is the subs. And then next, what I'm going to do is we had those front fills. If you just look back to how I had my if you look back to my system, and I had them, I hid them because what happened with this is I designed this system and I talked to the shop manager and he said, oh, we're not really sure what kind of front fills. They're either going to be Kiva 2 or Kara 2. We're not sure whatever we have available. So I may be coming to the gig with Kara 2 or Kiva 2. So that's unclear. And that's why I chose to hide those when I went into Network Manager. So now when you go in here, I'm going to add some amplifiers and create a custom preset based on whatever front fill speakers come off the truck for me that day. So in this, back to my window here, hopefully, there we go. So now on the left here, I'm just going to click, I'm going to add an amp, I'm going to add LA12Xs, I'm going to add 2 of those, and I'm going to drag them over here. By default, they loaded the SB 1860. So what I'm going to do next is I want to convert those, I want to have an amplifier on house left and an amplifier on house right to run my Kiva 2 and Kara front fill speakers. So I'm going to click on the L-Acoustics logo on the top left, and I'm just going to click on Custom Preset Builder. So in this case, very straightforward. What I can do is I can select multiple presets and bring them over to my workspace here on the right. So what I'm doing is I'm looking at these. I'm looking at Kara. Here's my Kara preset. I'm going to use my Kara FI preset, Kara FI, and then I'm going to also load Kiva 2 FI preset. So FI standing for fill. So I'm clicking and dragging those over into the workspace. So in this case, what I'm going to do next is I'm going to click and drag each of those down to the area where I'm going to build out my custom presets. I'm going to start with Kara, and Kara goes down, and that is now occupying channels 1 and 2 of the 4-channel amplifier. And then PA, obviously, for passive. So it's passive for Kiva 2 and passive for the second channel of Kiva 2. So in this case, you can see the channel set nomenclature for the Kara, LFA, and HFA. That's a channel set for the Kara. And we have the Kiva 2 is a passive enclosure. We don't have multiple channels occupied by that preset. Just a note, guys, we talked about low latency preset. At the time, we can't, obviously aren't going to be able to mix and match standard presets with low latency presets. So be aware of that if you're building a preset for monitoring applications. So I'm just going to give it a name that makes sense. Whatever I type in here is going to show up on the front panel. So I'm just going to call this Kara, maybe Kara plus Kiva 2, and that's good. I can, cool kind of shortcut here, I can press the enter key, and by doing so, it carries the name down to the preset file name. So you can put this in down here. I know a lot of people will, you can extend the file name into here, so you could use a more detailed to indicate what channel sets are which. I'm just going to leave this like this for now to show you the next feature, which I find very, very handy. I'm going to hit Save Custom Preset. And now it puts it in a file location in Finder on a Mac or in this Explorer in Windows. I can click this, and now you can see any lists of any presets that you've saved previously. But the great thing about this whole thing is if I forget what my channel outputs are, I can click on this preset inspector button and click on any of those presets. And what it does is expands a window to give you more details on how those presets are configured. So what the preset name is, what the preset version is, and most importantly, what channel sets, what bandpass outputs are assigned to each output of the amplifier, and any kind of other adjustments you've made to that custom preset. So that's really great. From there, I'm going to click the X in the lower right-hand corner. And in this case, then I'm going to click on highlight my 2 LA12Xs that I'm going to designate to designate to my front fill amps. I'm going to click on more preset options, run through that real quick, and here's my custom preset. I'm going to drag into my file location. You can see by doing so, now I've loaded off of the default SB1860 preset, and I'm loaded now my custom preset, which I've named Kara plus Kiva 2. So I'm going to click off of that, and in that case, now I've got my custom presets there. I'm going to create some groups. I'm going to call this one front fill. We'll call this left. We'll call this Kara left 2. We'll call this Kiva 2 left 1. And Kiva 2 R1. So I'm going to drag these over here so they make sense with what I'm doing with my system. And now I'm going to associate these groups with that channel sets and those custom presets I've built. So remember, my Kiva 2 left is going to be only the second, these two outputs. And I could even deselect those if I'm not using all the outputs of the amplifiers just by clicking the plus minus. So that's good. Do that. And then I'm going to click on this other side and select those. And I'm going to do the exact opposite with my Kara outputs, deselect, oops, not that side, I want to have my separate group for that side. And I can do this and deselect those. I can just quickly pop through each of these plus minus selections to make sure I've done that correctly. I'm going to create a new group. We'll call this group front fill. And from here, what I can do is just a quick reminder is then I can actually use the lasso tool by clicking here off and selecting each of these groups just by running that lasso tool through the other groups. If I made a mistake and added something I don't want to, I can double click on this. And when I move my mouse away from the group, you see it says removing. So anything I were to run my mouse through now, it would remove it from the group. I'm just going to single click there. It says add. So there we go. Pretty straightforward with that. I'm going to add a P1 for my front end. So I'm just going to click add P1. I'm going to bring that maybe up to here, and I'm going to add some groups for that. I think the examples yesterday were left, right, sub, and fill. So I'm going to, just so you guys can kind of see this, see how we add DSP groups to the P1. What I'm going to do then is quickly here, I'm going to click on my P1 and deselect the groups I don't want to use. So now I've got left, right, AB. I've got my fill. Oh, that's our fills is bus D, let's say. And then I've got my sub, and that's going to be on bus C. Now I'm going to rearrange my groups so they make sense to how they're outputted in, or how the groups are assigned, DSP groups are assigned in the P1. So that being said, just take note that these groups are blue, indicating that they control P1 DSP groups and not amplifier control groups. So that's all good. I'm just going to save this. I probably should have saved it earlier. So again, in this case, what I'm going to do is we'll call this our SBB tutorial start. So pretty straightforward there. And now I'm just going to quickly pop over to my tuning page so you guys can see some of this stuff before I go online. So here I've got, if you click on as we've all seen before, then in each of these control groups, I've got my array morphing tool, my EQ station, my gain delay, and my LF resources. Now, different from those groups is the P1 groups, which if you go to the EQ tab here, they have all 16 of my IR filters. By default, I can switch those to high pass, low pass, high shelf, low shelf, and notch. And then also just noteworthy here is each of these groups within the array, the line source, has different amounts of FIR filters to homogenize HF response over that venue. So that's in there. And then we'll get a little bit into it more here in a second, but I'll talk about Autoclimate here in a little bit. But from the P1, I can also just click here and I can see I've got a little bit of a graphics issue here because of the I think because of the webcast. But what I'm able to do there is select and adjust faders per group. And then I'm also able to use my matrix mixer in there as well. I'll show you guys that in the presentation slide here next. So quickly, I'm just going to go in really fast here, back to the presentation so we can talk about some of the other features. And we'll make this big again. So within the amplified controllers, then we've obviously got our load checker. This is in the case of LA4X, LA12X, LA2XI, not listed there. Does not work with LA8. Obviously helps us to mismatch between a loudspeaker and preset selection, cabling issue, component integrity. So from here, and I found this a very handy tool, when you run this, you need to designate a temperature from the to test in addition to the cable length and the gauge of the cable. So use this to your advantage. What you can do is, just kind of a quick feature here, is we can use our network manager environment to use the probe from our P1, you can see here, to get the temperature for the system. So just kind of overview what we talked about a second ago. These source groups plus associated amplified controller groups, we're going to tell it what type of system we're using, and then we're going to be able to go over those kind of things, go over that. The hierarchical groups, that becomes the groups you create in you can see on my screen here, you can see the main group is the parent group to those sources, and that's the highlighted in blue there. So you could obviously do all of this stuff ahead of time as you're preparing for going on site, part of the calibration process. Zoning groups, each of these zoning groups contains the auto FIR filter sets like we just saw from each part. And then you obviously would control source groups, array morphing, IAR, FIR, plateau, and then in the zoning groups, contour FIR groups, including air comp for those as well. I'll show you guys more about air comp here in a second. Another thing that's really, really handy is you can synchronize an XMLP file with an updated EQ. So again, before visual distinction of groups that can be synchronized, preventative warning if user action removes the synchronization option. And then, so the best use for this, I would think on a day-to-day example would be if you load it in the morning, you design your system and the atmospherics change, you have to update the stuff. You can re-execute the algorithm in network or in Soundvision and synchronize that XMLP file with the network manager file to update the FIR filters for that specific atmospheric change. So we did talk about it. I'll start with this real quick. The Autoclimate for imported groups. So when we import our Soundvision file to Network Manager, we're able to take advantage of Autoclimate. And what Autoclimate allows us to do is adjust the HF contour of the system in response to changing atmospherics. So it's going to take advantage of adjusting all air comp filters proportionally based on the targeted distances predicted and resolved by the AutoFIR algorithm in Soundvision. So if you look here on this graphic on the right, you see reference, and that's the temperature and humidity settings that are predicted in Soundvision, and then suggested. What that allows us to do is we can update to either the current temperature set from the P1 or just enter manually here. I'll show you that. I'll pop back into Network Manager here momentarily, and I'll show you how to do that. So I think what's important about this whole thing is we can take advantage of Autoclimate based on critical listening. So in the case of critical listening, we can increase or decrease the contour of HF in the system based on what the aesthetic goals are, regardless of the atmospherics. If you update to the current atmospherics, it doesn't automatically change the HF quantity. You have to adjust that with the fader.
Yeah.
So then, go ahead. Go ahead, Francois.
Yeah, I think it's quite important to address this because the name of the feature itself can be misleading. So it's really important to understand that this is not automatic. So this is when we enter some new condition, we have a suggestion for where you could put your fader, but this is really important to understand this because this is mainly a live tool, meaning that this is during a show that maybe the conditions are changing and you want to address this change of HF absorption by using this master control over the HF contour. So we need it to be really not automatic, but you can smoothly go from one setting to the other or not, depending on what you are listening to. So yeah, so this is really a live tool. When you are in a tuning stage, it's always better to go through the synchronize function, I would say.
Mm-hmm.
And so it's not really a tuning tool, but mostly a live tool. So that's one aspect of it. And again, it's not only about climate. So even if you have no idea about the new condition, the fader is still working. You can just by critical listening or by looking at a reference measurement, just apply the setting, play with the fader. You don't need to know about the current condition. And last but not least, you don't need to have a P1 to use this feature. So if you have a P1, you can recover the atmospheric condition from the probe in the P1, but even though you don't have a P1, this Autoclimate tool is fully functional, usable. So that's, I would say, I tried to answer quite a few, I would say, regular commands that we have on this tool. So I think it was good to talk about this a bit.
Yeah. And real quick, I'm just going to go back into Network Manager here. I just had this up. Obviously, you saw Autoclimate. But what I'm going to do is I'm going to save this. I'm going to take this online. So you guys can see a couple features here. I've got a P1 and the LA4X set up. So I'm just going to go online, and I'm going to click on here, and we'll see what happens. Remember, in this case, up here, I can click. I have two devices on the network. I'm just going to go into Unit Matcher, go back into setup mode, and these views are just other things on my Wi-Fi right now. So I'm going to move the IP address to of these units to the virtual units in the network. And again, if I was setting this system up for a show, I wouldn't have other devices like this on the network, but I need to be on the Wi-Fi to talk to the world. So here you see this comes up as yellow. The reason it's yellow is because there's a unit type conflict. I had specified an LA12X, when I have an LA4X in use. So I'm going to click on Solve Unit Type Conflicts, and that will convert the files specified LA4X, or convert what's in reality, what's in the real world, the physical world, with the virtual LA4X. Again, realizing that Kara and Kiva 2 will work on an LA4X. This wouldn't be a good approach if you were using, let's say, K1 or KS28 or something. We wouldn't be able to use an LA4. The second thing is coming up and says, hey, there's a problem with the family because the presets in at SB18, you're trying to run a Kara or Kiva 2 preset. So I can click on the Solve Family Conflict button here. And what that does is now loads the presets that are in the virtual environment into the physical environment. And now I'm ready to go back online. Another kind of handy feature here is this identify tool. I can click on this, and what this will do is flash the front panel. So if you're trying to troubleshoot something, it's easy to identify where the problem is. So that's a really great tool. And I'm going to click the X to go back into my environment here. And why I did this is I just wanted to show you this, the Autoclimate feature here. So I'm going to turn on, I apologize, there's my graphics issue here. It's kind of showing a low-res version of this. But now you can see what the atmospherics are of my P1, the atmospheric sensor in my P1. And what I can do is I can either update those, I can update this manually, like Francois was saying. You can click here and I can type in any value. I'm just going to change this to say 22. And maybe humidity dropped a little bit. Maybe it's more like 40 now. And now it says, okay, right now the system was designed to work at 20C, 60%, but the suggested is up here. So I'm just going to click on these FIR groups, and now I'm going to look at this. I've just clicked on one of the top, maybe I'll click on one in the middle here, the system, and I'm going to click and drag this fader up and down, and you can see it's moving the air comp value up and down proportionally through the system. And I think the important takeaway word there is proportional. It's doing this gradually across the whole system, so HF response is homogenized as possible, and it's doing it to maintain good headroom resources in the system. So I can do that. I can do this to taste as needed. Down here, it'll show these graphics. If I can get this to come back, maybe I have to go back to here. You can see my max, my min amount of air comp, and my average air comp being consumed by each of the systems that have air compensation filters applied. I can do this. I can import this data directly from the P1 sensors. So here I've got my P1 probe in front of me here, and I can just click this, and by clicking this P1 IP address 28, what it does is, there it is, and what I can do then is now it moves that suggested bar to what the current state is of the P1 to atmospheric probe. So be careful, because you don't want to leave the probe out in the sun or something, or it's magnetic. Don't attach it to the back of your doghouse that gets hot. That won't be accurate information. So that just does it a quicker method to get those atmospherics into the system. So real quick, then I'm just going to go, we'll go back to the presentation slides real quick. I think it's right. It's not that one. It's this one. There you go. So I think that's like Francois said, it's the name can be a little confusing. You can obviously enter this data in and use it as an aesthetic tool throughout. So then in this case, here's the P1 distribution matrix. In this case, in the new version that's coming out shortly, we're going to have 8 DSP buses, and you can see on the top here where we've collected all of our inputs and how much is being applied to each of those. Each DSP bus gain-wise, the dark gray means it's on, the light gray means it's off. There, you can gang those together, and you can also meter inputs and outputs. These tabs down here allow us to see that. Unfortunately, my graphics aren't going to allow me to show this live, but you can see from this presentation slide, and I think Tony went through this pretty extensively yesterday. From our P1 DSP bus, here you can enter values for each of these, so you can select your filter and then your type. The important thing about the high pass and low pass filter, I think, is important, is you can stack those to increase the order or how steep your high pass or low pass filter is. Let's say if you're sending to like an under balcony system or something like that, you could high pass that and then increase the order of the filter by stacking to the same frequency. It gives you quite a bit of freedom to really use this as a effective DSP. So we have 2,000 milliseconds per bus, 16 IIR filters, and we talked about that. And then high pass filter, low pass, obviously peak input limiter. That being said, here you have metering. My input meters on the left. It says ABB lock. It's going to show you what kind of signal we have connected. Here you can see output meters, and you can see on the P1 processor output metering as well. In the case of these amps, you can see the temperature, the P1, and this is actually a slightly updated graphic. I'm going to show you a pretty handy feature here then in Network Manager as well. What I can do quick is I can just go to my live page and I can click on my P1 and go to unit temperature, and in my unit temperature it's going to show the internal temperature of the unit and also the temperature of the unit, the USB sensor. So if you had multiple P1s on the network, you could have some kind of cross-reference to verify your temperature is correct. Or if you had one at a delay position, you could have build some kind of weather matrix to get a more accurate idea of what the show site's like. So that's, let's go back here and finish up real quick. And in the case of LA12X, it will monitor input voltage as well, samples every 1.5 seconds. So again, I also find that handy to use for when I'm going to do load checkers to pull up that temperature information that's on the P1 sensor. At the top of the toolbar, it will show you any kind of errors that have occurred. And in this case, what we're looking at is fallback. So it's important to note here that if a fallback is introduced, it will turn red. When the original signal comes back online and is valid, it will turn orange. But you, as the user, need to execute the return to the priority signal. Well, that's an important thing to realize, is that it's not going to toggle between fallback priority and secondary signal, or priority and the fallback signal without you initializing that, because it allows you to troubleshoot the problem properly. So, and I mentioned it before and I didn't get into it. I'll just go to this page really quick, and you can see if you go into your setup page and click on your P1, and in here you can see, or any of your controllers, you can see from here, you can select gain compensation to account for input changes in level from original to secondary, or to priority to secondary sources, input sources. Cool. I've been toggling through all the presentation, all these different applications, and trying to show you guys various things and things like that. I haven't had a chance to look at the questions, but Francois, anybody else, any questions or any things you want to add to this conversation?
I don't know. From what I see, there are a few questions still on the Autoclimate. I think two are links. One was a comment by Erika. So hi, Erika, by the way. It's been a while. So the Autoclimate again is going to work only on the air comp filter that has been created through the importation of a Soundvision file. So that's quite important to understand. It's not going to act on the FIR filters, by the way, but only on the air comp. And so it's not an additional group. This is you need to see it as a modifier of the existing air comp filters which are in your file. What else? I think that was the main question that I can think about. Anyone else? No other moderators with tricky questions that they want to answer live. So if not, I think we can close this session.
Yeah.
So again, thank you, Vic, for this overview of our training module. So again, we hope that we'll be able to deliver this training for real in face-to-face as soon as possible. Meanwhile, stay tuned for our webinars. So we're going to entertain you a bit more. So not only entertain, but sometimes trying to educate you a bit, or at least to give you some interesting information. So depending on each topics, you can have a look on our webpage. We'll announce soon the topic for next week. So yes, thank you all for attending all our webinars, and the replay is going to be available on YouTube. So thank you all. Bye-bye.
Yep.
Thank you.
Thanks, guys.
Gracias.
Thanks for your attention.
Bye-bye, everyone. I don't know if anyone has a chance to share the screen capture that I just did on our chat about the P1 probes. So when you have multiple P1s, there was a question. When you have multiple P1s, in the Autoclimate, you will have multiple buttons, up to 3, and you can choose which one to take the reading from. I don't know if anyone can see in our chat and share the screen. I can't do it because that was that question. I've just done a screen capture. I don't know, Vic, if you could put this on the screen, but maybe that answers the question.
Let me try to do it. Hold on.
So I have 2 P1s. I have 2 buttons on this one.
Yeah, it's going to be tough. I don't think I can do it, but they are. I guess they are side by side.
Yes. So generally it's the same as 1, but you have more than 1 button representing each P1. If that answers your question. That question was from Xavier. But anyway, thank you very much, and that's it from this side.
Okay. Thank you all. So bye-bye.
Bye-bye.
Gracias. Chao. Adiós.